Today we're going to talk about 13.6, the law of cosines and areas of triangles. So our essential question is, how do you use the law of cosines to solve triangles? And our other essential question is, how do you find the area of triangles? So we're not going to do like 1/2 base times height for the area of a triangle, because you would have to have a base and a height. And in these situations, you're not going to be given that information, but you will be given some other information. So this is unique or new to you. All right, so let's start with law of cosines. We already learned about law of sines. That was a pretty challenging one, because that sometimes you would have an ambiguous case if you were given ASS or SSA, ass or ass backwards. So that one could be a little bit challenging to use. This law of cosines that we're going to talk about today, this one is pretty straightforward. And there are two specific scenarios when you'll use this. Okay, so law of cosines. You're going to use this when you have side angle side. So that's where you have two sides and an angle that's included, or all three sides. So side angle side might look something like, if I have a triangle, I have a side here, I have this angle, and then I have another side. So I have this angle is touching both sides that we're talking about. Otherwise, if it's not included, then we're back to ass, right? If I had an angle here and then these two sides, that would be ass. Okay, so law of cosines, super straightforward. Let's see, I'm going to draw us a triangle over here. I'm going to have triangle ABC. So this will be side A, this will be side B, and this will be side C. Okay, and really there's just one way of thinking about this, but I'm going to write it for all three different angles or sides. So if I take some side, like A, and I square it, that's going to equal the same as C squared plus B squared, so the other two sides squared, minus 2 times those two sides, C times B, and then cosine of the angle opposite the side that I started with. So I can do that for any side. So if I wanted to do it with B, this would be B squared equals the other two sides. So instead of B, I'm going to have C and A. So A squared plus C squared minus then 2 times those two sides, A times C, and then cosine of the angle that's opposite this side. Do it one more time. But you don't have to memorize each one of these. You just kind of have to memorize like where they come from. So I pick a side, maybe a side that I either know or need to figure out. So for example, if I need to figure out C, then I would use what I'm about to do. If I need to actually even figure out side C, I would probably use what I'm going to do right now. So I'm going to take C, square it. So now the other two sides together get added and squared, minus 2 times those other two sides, times the cosine of, and then it's the side or the angle opposite this side, which is C. Okay, so that's the law of cosines. It's pretty straightforward, it's pretty easy, and it's always going to work as long as you have side angle side or side side side. Okay, so let's do a couple of these. Example 1. We're going to solve triangle ABC with A equals 12, C equals 16, and capital B equals 38 degrees. A lot of times it's helpful to draw these out. So I'll go ahead and I'll draw one out that'll fit nicely in here. How about that? So we'll call this B, which is 38 degrees. So then B opposite it. Okay, and we have to solve this triangle, so we have to find every single part. How about, what else am I given? I'm given side A. So A is 12, so I'll call this angle A. And I'm given side C, so this will be angle C, this will be side C, which I kind of have to write inside because I made it small. So it's nice to have that in front of you so that way you know what you're looking for, right? I know I'm looking for these two angles. I'm also looking for side B. All right, so the first thing I'm going to do is well, first of all, let's just double check what I have here. I've got side, angle, side. Okay, if I didn't have side, angle, side, so if I had like angle, angle, side, or something like that, I wouldn't be able to use law of cosines. But since I have side, angle, side, I can use law of cosines. And I'll start with, because I have angle B, I can use that to help me figure out what side B is. Okay, so that's probably like the most direct thing that I can do. So I'm basically going to say to myself, well, let me start with this side because that's what I want to find out. So that'll be my B squared equals, and then I take the other two sides, right? So 12 squared plus 16 squared. So just like imagine you're following this one right here. But really, any of them work. You just have to basically, whatever side you're starting with, those aren't the two sides that you add together, right? You take the other two. Okay, and then from that, I'll minus 2 times, now those other two sides multiplied together, 12 times 16, and then cosine of angle B, which is actually 38 degrees. So this should be pretty straightforward math, although people will make mistakes on this a lot. Okay, so you really need to follow your order of operations. So I'll start with my exponents. So that's 144 plus, I think that's 256. I think I'm doing that right. Now I'm just going to get out my calculator. I don't know what 12 times 16 is. And then multiply that by 2, 384. And then I'll figure out what cosine of 38 is. Let's make sure I'm in the right mode. I am. Okay, good. I was just double checking. So 0.788. I think that's probably enough significant figures there. So times 0.788. And actually what I'm going to do while I still have that in my calculator is I'll multiply that by 384. That way I didn't really have to round in that calculation. So this will be minus 302.596. And 144 plus 256 is 400. So now I can take 400, subtract, and I'll actually go back up here and grab that 302 number. Okay, so I get B squared equals 97.40. How about I go 387, just so I'm not rounding too much yet. And now to actually solve for B, I need to take the square root. So I'll do the square root, and I'll go back up and I'll grab that number. So B is approximately 9.869. Okay, and I'm going to, you have to be really careful because if you round a whole bunch back up here, every time you round and you keep using that for calculations, your answer is not going to match this one. It's not going to match what's in the book. It's going to be way too estimated, way too rounded, okay? So just be careful with that. Try and use exact numbers as much as you possibly can. Kind of by going back up and using your calculator, I think that that's pretty helpful. So side B is approximately 9.869. Okay, so that was the first thing I did. So actually, why don't I go ahead and I'll write little steps here. So my first step that I did was I found my last missing side, so find B. All right, second thing. All right, so when we look at all of our sides, right here, this is our smallest side. Well, we already have the smallest angle. And as I do this, I'm going to continue to find the next smallest angle. Okay, so that the last thing I find is my largest angle. Okay, so I'm going to put a little star here. Find smallest angles. first. So I have the smallest angle. I'm now going to find A, which is going to be like the second smallest angle. Okay, and then I'll find the last angle, which is going to be my largest angle. Okay, so I'm going to find measure of angle A. Since it's smaller than angle C. Okay, so from this point, let's see what I have here. If I need to find angle A, well, look, I have a couple things here. I have like, as far as information goes, I have an angle and a side and a side. So I can use law of sines if I wanted to kind of make this simplest for me, because law of cosines is quite lengthy. So I think I'm going to do that. I'm going to go ahead and I'm going to use law of sines, and as long as I have, as, I can do that. I also here have side angle side, so I could potentially, let's see, if I wanted to find angle C. Oh, could I do that for angle A though? Oh, I could do it for angle A as well. Finding angle A will be a lot like another one I'm going to do, so I'm just going to go ahead and I'm going to use law of sines. Okay, so I have as. I know I have one triangle though because I was originally given side angle side. Okay, so I know that it's just one possible triangle. But I have as, so I can use law of sines. Okay, so that is like sine of an angle over the side opposite it. So sine of 38 degrees, which is angle B, over the side opposite, which I now have, which is 9.869. And yeah, I'm approximating. Equals, and then I want angle A, so sine of angle A equals, and then that's going to, or over, sorry, side A, which is 12. Okay, cross multiplying then, I get 12 times sine of 38 degrees equals sine of A times 9.869. I'll come over here. So then I know sine of A will equal 12 times sine of 38, and I'll have to divide both sides by 9.869. So then A is actually going to equal the sine inverse of this chunk up here. Okay, so let me put that in my calculator. I'm going to go back and put my numerator all in parentheses. It's just a good habit. And then I'll divide that by 9.869. Do I have a few more? Nope, I didn't write any more. That's okay. Alright, so I know now that, I'm going to write it over here, A is approximately 48.469 degrees. And from there, I think the last thing I have to do is find angle C. So I can do that really quickly by just subtracting that. I'm out of room though. I'm going to have to go on the back. So I'm going to find the measure of angle C by basically saying, well, I have my other two angles, so I'll add those up and subtract them from 180. So third step here. Oops, not angle 3. The third angle, but angle C. Alright, so that's going to basically be 180 minus the other two angles, which was 38 and what I just calculated, 48.469. Okay, and then so I'll just do that really quickly. 180 minus 38 plus 48.469. And that ends up giving me 93.531. And these are approximate. But now I've solved everything, as I can see by just looking at the triangle that I've drawn. All right, let's do another one. So example 2, we're going to solve triangle ABC, where A is equal to 8 feet, B is equal to 18 feet, and C is equal to 13 feet. So if I draw myself a nice little picture over here, let's see, A is 8 feet, B is 18 feet, and C is 13 feet. All right, well, it appears that A is going to be my smallest angle, so I'm going to go ahead and find that one first. So, oh, I didn't even say this. Look at what I have. I have side, side, side. So I should be, in fact, using law of cosines, because that is when I use law of cosines, is when I have side, side, side. Okay, so I'm going to start with finding angle A. So that means I need to start with side A. So I'll do 8 squared equals, then the other two sides, I square them and add them together. 18 squared plus 13 squared. Oops, not C. Minus, now 2 times those two sides, 18 and 13, times cosine of the angle opposite the side that I've got here. So that's cosine of A. So I end up with 64 equals, 18 squared. Well, let's just solve that. Oh my goodness, I'm just taking a long time. 18 squared, here we go. 324. And that's 169, I know that one. And then 18 times 13 is 234 times 2 is 468. Now, a lot of times what people like to do is they like to just go, I'm going to add this, and then subtract that. But you can't do that. According to PEMDAS, you got to multiply first, right? So this is very tricky. People get really messed up here, okay? So this 468 is being multiplied to cosine of A. You cannot sum it into this stuff. Okay, so let's see. 324 and 169 is that. So I got 64 equals 493 minus 468 cosine of A. So these cannot be subtracted. Instead, what you're going to do is you're going to get rid of that 493 by subtracting it from both sides. So 64 minus 493 is negative 429. And then I still have the negative 468 times cosine of A. Now, how do I get rid of that negative 468? It's being multiplied to cosine of A, so I divide it. All right, so let's see, 429. Should I just leave it like that? I think I'm just going to leave it like this right now. Actually, it'll be positive, so I won't have the negative. I think I'll just leave it like 429 over 468. Now, how do I solve for A? Well, I need to get A by itself, so I need to do cosine inverse, right? So cosine inverse of 429 over 468 will give me whatever A is. So let's put that into my calculator. Cosine inverse of 429 divided by 468. And I get 23.556. Okay, so I got angle A, which I'll put right here, which is 23.556 degrees. So now let's see, from there I've got side angle side. That's not going to help us, right? Because side angle side is still law of cosine. So we're going to continue on using, let's see, I don't think I can do anything else. So I have angle side side. So I can use law of sines. Maybe to find, will that be enough information to find angle C? It will, yeah. So I'm looking at this and I'm just thinking to myself, look, I got this side, and this angle is opposite that side. So now I can go over and use law of sines. I know it's one triangle because it was given to me as one triangle. I was given side, side, side. That defines a triangle. But now I can go ahead and I can find law of sines. So here, oops, I didn't write it. So first let's go back up here. First thing is find smallest angle. Okay, sorry. Keep forgetting to do that. Second thing is now I can find, because I've got as, right? I've got angle, side, side. So now I can use law of sines to find the next smaller angle, which is going to be C. So as to find, oops, as, so use law of sines to find angle C. Okay. So I said law of sine, so I'm going to do sine of A, which is sine of 23.556 degrees, over side A, which is 8, equals, and then sine of C, which I don't know, over 13. Then I'll cross multiply, so I'll get 8 sine of C equals 13 sine of 23.556. Okay, and now my goal here is to get C by itself. So the first thing I'm going to do is divide by 8. So now I got sine of C equals 13 sine of 23.556 all over 8. And now I'll do sine inverse of both sides. So I get C equals sine inverse of this junk, 13 sine 23.556 over 8. Okay, and then I'm going to just punch that into my calculator. So we'll do sine inverse of, oops, the whole numerator. I'm going to put in, so 13 sine of 23.556. All of that divided by 8. And I get C equals 40.498. So C is approximately 40.498. I should put degrees. And the last thing is find the last angle. By basically just subtracting from 180. So 180 minus the sum of the other two angles, which is 40.498 plus 23.556. And I get 115.946. So B is approximately 115.946 degrees. And I'll go ahead and I'll put it up here too. And my triangle is completely solved. Okay, so last thing that we're going to do today is talk about areas of triangles with no height. So if you weren't given a height, yeah, a lot of times you can draw in your height and you can figure it out using some trigonometry. But there are also some other scenarios. So if we want to find the area of a triangle with no height, and I'm given side, angle, side. Well, here's how this works. So let me just draw some random triangle. It's actually quite simple. So if I want to find the area, and let's say for instance, I was given sides A and C, and I was given angle B, right? So side, angle, side. Then it could be 1/2 side A times side C times sine of angle B. So it's basically 1/2 the two sides that are including the angle multiplied together times the sine of the angle that's included. So I'll write this 3 different ways, but basically that's what you have to remember. Whatever angle is included, you just multiply those two sides and then the sine of that included angle. So we could also do 1/2. Now let's say I was given A and B and angle C. Then that would just be AB sine of angle C. Or the other one is, let's say I was given angle A and I knew B and C. Then it's 1/2 B times C sine of angle A. Okay, so this could save you some time in the future because sometimes you're given these triangles and trying to figure out, okay, well, where's my base? How do I draw a perpendicular line? That's going to involve a lot of algebra and possibly some trigonometry with some angles. Depends on what kind of information you're given. All right, so let's do an example with this. We're going to find the area. And the area that we or the triangle we've been given, sorry. You have angle A is 55 degrees. This side is 3 inches, and this side is 5 inches. I realize I have side, angle, side. So to find the area, it's really simple. I do 1/2 of the two sides that include that angle. So I multiply those two sides together. And then I multiply it by the sine of the angle that is included, which is 55 degrees. And then going to my calculator, that's 15 times 1/2 or divided by 2, so that's 7.5 times sine of 55 degrees. And so my area is approximately 6.144, and our units were inches, so square inches. Pretty straightforward. Okay, so that's if you're given side, angle, side. That's another way to find the area, especially if you don't have a height or a base, right? You don't have like a height that's perpendicular to a base. Another thing that we can do, not for side, angle, side, but another way that we can find the area is something called Heron's formula, or some people call it Hero's formula. He was a Greek mathematician. And this one is used to find area of a triangle when you're given side, side, side. Okay, and here's the formula. So area equals, and I have to explain some of this to you, but it's really simple, I promise. This letter S, which I'll talk about in a second, times S minus one of the sides, S minus another side, and S minus the third side, in no particular order. Because multiplication is commutative, so it doesn't really matter. And this is where S is known as the semi-perimeter. So this is semi-perimeter, which is basically the average of the perimeter. So it's the average, well, it's not, I shouldn't say that. It's half of the perimeter, hence semi-perimeter. Okay, so it's half of all three sides added together. So I think the hardest thing about these are just remembering them. Once you know them, then they're really easy to use. So example 4, find the area of this triangle right here. So A, B, C. A is equal to 22, B is equal to 40, and C is equal to 50. So notice I'm given side, side, side. So then I know that I should be using, or I can use, Heron's formula. So I'm going to basically do, well, first I should find the semi-perimeter, I guess, right? So let's find the semi-perimeter. So that's 1/2 of all the sides added up. And that's 90. 112 divided by 2 is 56. Okay, so that's my semi-perimeter. So then my area, I just take the square root, I do my semi-perimeter times, and then I take my semi-perimeter and I subtract each and every side from it. So 56 minus 22 times 56 minus 40 times 56 minus 50. So this is really the square root of 56. 56 minus 22 is 34. 56 minus 40 is 16. And 56 minus 50 is 6. You could actually just type all that into your calculator if you wanted to. I'm pretty slow on my calculator, so I prefer to do a little bit more math first. Now I'm going to go ahead and type it in them. So I'll do 56 times 34 times 16 times 6. And I get 427.5324. Oh, and nobody gave us any inches. So we'll just say inches, or units cubed. We weren't given any units, I should say. And it's an approximation, so I should probably put that. Units squared.